Hey everyone. So what we're going to do today is learn how to graph exponential functions. Now there's two types of exponential functions, and the one we're really going to focus on today is we're going to worry about exponential growth. When I see you guys tomorrow, that's when we'll talk about what's called decay. All right, so when we go through and we graph these exponential functions, just like all of our shapes, is I want to show you guys like the basic shape first, and then we're going to move this graph and kind of stretch it up and down like we normally do. So with our basic shape, our normal basic function that we have is an equation like y is equal to 2x. Now, something that exponential functions have that other graphs might not is you have a horizontal asymptote. And in our basic shape, our horizontal asymptote is going to go right across the x-axis, and it's going to be on 0. All right, so that's where you guys are going to start. Now, with any basic shape, remember, we can start getting points by always making a t-chart, right? Because that'll help us try to get some points. So we can use this XY t-chart to help us out. Now, the easiest number to use for x in this case is definitely 0. And the reason why is because we know if we plug in a 0 for x, 2 to the 0 power is just 1. We know anything to the 0 power is 1. So that gives us a point of 0, 1 right there. All right, another easy number or value to use for x is a positive 1. And if we plug in a 1, 2 to the first just gives us 2. So that means that we go up 1. We go to the right 1, and we go up 2. All right, and there's another point. Now, even if you guys did want to make your x values negative, let's say we wanted to test out some negative values, and we want to test out negative 1. Well, when I plug in negative 1 for x, it's 2 to the negative first, but that actually ends up giving us a 1/2. So we would go to the left 1 and up a half. So I guess what I'm really trying to show you guys by plugging in that negative 1 is no matter what negative values you plug in for x, it's never going to go below your horizontal asymptote. So your graph is actually going to look something like this, where it kind of stays along the asymptote and then ends up going through your points. And since we're dealing with growth, this is going to grow upward as we go to the right. All right, so that's what your basic shape is going to look like. Now, you're not going to need to show me like a third point. For all of these graphs today, you only need to give me 2 points. I just want to show you guys that third on this basic shape to help you guys understand it a little bit more. Okay, so with any function that we've graphed this year, we always have like that standard form, right? And same thing here. We have a standard form that's going to help us out. So our standard form of exponential functions look like y is equal to ab to the x minus h plus k. And I just want to go through and identify some important things and what they actually represent. So the first thing is h. And if you guys remember h from any of your other basic shapes that we've talked about, h is what we refer to as our horizontal shift. So this is going to move our graph left and right. All right, when we get to K actually represents two things. One, it represents your vertical shift, so it's going to move your graph up and down. But K also represents that horizontal asymptote that I first plotted on that basic shape. Let me see if I can get that all on the same line. All right. So that K value is going to be your shift up and down, but it also represents where you're going to put that dotted line that we started out with that basic shape. All right, your A value, you guys actually aren't going to really see too much, but your A value is either going to be positive or it's going to be negative. That's it. It's not going to be much more than that. Only thing to know is when it is negative, that just means that you are flipping it. It would just flip over the asymptote and kind of look like it'd be going upside down. All right, now the last thing I want to get to is B. And B is probably the most important thing when you're graphing these exponential functions. And why B is so important is because B tells you whether you're working with a growth or decay type of problem. So I'll put that here. All right, so B, that base number of B, allows you to know whether you're working with growth or decay. Now, how you know you're going to work with growth. All right, so you know that you're working with a growth type of problem if B is greater, let me space that out. If B is greater than 1. So anytime your base number is bigger than 1, that's when your function is going to look like a growth type of shape, or it's going to look like what we saw over here on our basic shape. So if your base number is greater than 1, it'll be considered growth. I'll show you guys tomorrow and explain tomorrow when that B value is something different when it represents decay. Okay. All right, so now that we have all of these kind of basic understandings of standard form, let's go through and actually try to apply these to some specific graphs. So if I scroll down here, all right, there's going to be 4 graphs that we're going to go over today based off of using our standard form to actually get this shape. All right, now when you guys are graphing these functions, I gave you, if you look over in the bottom right corner, I gave you a list of 3 steps that you guys can take a look for and follow, and that'll help you graph all of these. And again, I know I kind of said this in that basic shape, but when you go to graph these, you only need to give me 2 points. You never need to give me anything more than 2 points. Okay, so let's look at number 1 first. So the first thing is, if you guys look at this function, we have y is equal to 3 to the x power. The first step says that you want to plot your horizontal asymptote. If you go back up to standard form, you guys will remember that your horizontal asymptote is that k value, right? So that's going to be whatever's at the very end of your standard form. That's going to tell you where you're putting that horizontal asymptote line. So in this case, on problem number 1, if I look at the very end outside of 3x and I don't see anything there, that tells me my k value is actually 0. So I'm going to plot my horizontal asymptote right along 0, which is going to be right over that x-axis. That's my first step. Okay, your second step is you're going to plot the first point. And that first point is either going to be above or below your asymptote. And all it depends on is whether your base number is positive or negative. So if I look at that base number being a 3, first off, I know that this is definitely going to be a growth problem. But as I look at that 3 and I see that that 3 is positive, that means that I'm going to go from my horizontal asymptote and I'm going to go up 1 unit. Again, because 3 is positive. So that gives me my first point. All right, your third step is you're going to plot your second point using B. And I'm going to explain this slow because usually this is kind of where it gets a little weird. But when you guys are looking at your base number of 3, that base number of 3 represents the distance from your horizontal asymptote to your second point. So what we're going to do is we're going to go back to our horizontal asymptote right underneath the first point that we plotted. And since my base number is 3, I'm going to hop up 1, 2, 3 units. Now we're always going to run to the right, and we're always going to run 1 unit to the right. But if you look from that second point to your horizontal asymptote, that's a distance of 3, which is why that base number, like how that base number affects this problem. So again, we go back to the horizontal asymptote right below the first point that we plotted. We're going to hop up 3 because our base number is a positive 3, and we always run 1 unit to the right. So those 2 points now, they look like they're forming that exponential growth shape. So we start by going along the asymptote, and then we go up as we go to the right through those 2 points. And that gives us a graph that looks like this. All right, so let's look at number 2. All right, so when you're looking at number 2, you have y is equal to 2x plus 1. So if we go back to our 3 steps that we have, the first thing is you want to plot your horizontal asymptote. So remember, your horizontal asymptote is always what's happening at the very end. So when you see a +1 at the very end, that tells you that you're shifting this up 1, or that your horizontal asymptote is going to go through +1. So it's a little bit different than problem number 1 because now we see that shift up. All right, my second step is to plot that first point, and it's either, again, 1 unit above or 1 unit below. Since I look at my base number and I see that my base number in this case is a +2, that means that positive tells me that I go up 1. So I'm going up 1 from my horizontal asymptote, staying on that y-axis. Now my third step is to plot the second point using, again, my base number of 2. And we know, just like problem number 1, that this is a growth type of problem. So it should have the same shape as number 1. But since my base number is a 2, I go back to my horizontal asymptote and I go up 2 units. And I start right below that first point. So I hop on that first point is 1, then on 3 is 2, and then I always run to the right 1. So again, from my horizontal asymptote, I hop up 2 and to the right 1. And that gives me my second point. All right, and again, that distance from your horizontal asymptote to that second point, that's your base number. So that distance is 2, which is, again, why our base number is so important. So now that you have those 2 points, you're going to go through, connect those 2 points, and form that exponential growth shape going up as you guys go over to the right. All right, so let's look at 3. Okay, so when you look at 3, again, you know you're working with a growth because my base number is a 3, which is definitely bigger than 1. So the first thing I want to do is plot my horizontal asymptote. So I'm going to look at the very end. I see a -1. So that tells me that I'm going to go down 1, and that's going to be my horizontal asymptote. It's going through -1. Okay, my next step is I want to plot my first point. Now, when you plot your first point, in this case on number 3, you have to be careful. If you notice in this problem, we now have something with x, right? There's an x -2. So I know I'm looking at this 3, and this 3 is positive. So normally I would just go up 1 and I'd be done. But because that x has a +2, and that x has a -2 next to it in the exponent, h, just like always, is opposite. So what that actually tells us, if it's an x -2, is that we have to go and shift this thing to the right 2 units because h is always opposite. So I'm not just going to go up 1 on this problem. I am going to go up 1, but I have to go to the right 2. So my first point is not going to lie on my y-axis like I did for problems number 1 and problem number 2. Anytime that you have a value being added or subtracted from x, that's going to tell you a shift left and right. And that's how far you have to run either left or right just by taking the opposite of it. Okay, so now after you take that -2 and that tells you that you run right, now you're on your third step where you have to find that second point using your base number of 3. So when you are using that base number of 3 and you start to count up 3, you want to start at the asymptote right below that first point. And right below this first point, when I count up 3, I end up right here, but then I still have to go to the right 1. That looks confusing. Let me get rid of that. So again, I start below the first point, and I count 1, 2, 3 up, and I run to the right 1 unit. And that gives me my second point. So then my graph, in this case, would be shifted down 1 unit and to the right 2 units. So that's why that first point is not on the y-axis. But the distance between your second point and your horizontal asymptote is still your base number. Your distance in this case is still 3. Just be really careful with that shift with x. Okay, so the last one we're going to go over is a problem like number 4. And the one big difference on number 4 is you guys are going to see you now have a negative out in front of that 2. But for most part, we're actually going to kind of block out that negative for a little bit. But I'll explain that once we start hopping into this problem. Okay, so on number 4, the first thing you guys want to do, just like always, is plot your horizontal asymptote. Well, since you see nothing happening at the very, very end, your horizontal asymptote is just 0. So you are going to plot that dotted line right on your x-axis. All right, now remember, your first point that you have to plot is your second step, and it's either 1 unit above or 1 unit below that asymptote that you just made. Well, in this case, since I'm looking at my base number and I see it's a negative 2, that tells me that instead of going up 1 like I've been doing, I actually have to now go down 1. But before I just go down 1 and plot that point, again, I see an x plus 1 over here, right? So that x plus 1 is telling me that I'm not only going down 1, but I have to go to the left 1 because I'm going opposite of whatever number is with x. That's my shift left. So that first point in blue, that'll be your first point of this graph. Now your third step is you want to plot your second point using that base number. So since your base number is a negative 2, that means you're going to start at the asymptote, in this case right above that first point that you plotted. You're going to hop down 2 from the asymptote, and we're still running to the right. And you end up being on the y-axis at negative 2. It's kind of off. Let me do it again. So you end up being right here. All right. Now, in this case, I know these 2 points are below your horizontal asymptote, so they're not going to look like problems 1, 2, or 3. This graph is going to stay along your asymptote from the left, but then go through those 2 points and actually go down as you're going to the right. Now, the reason why this graph is still technically considered growth is because as you're going from left to right, I know it's decreasing, but it's decreasing at a growing rate, if that makes sense. It's decreasing at a rate that's constantly getting bigger. So that's why we still consider problem number 4 growth. All right. I know I said whenever b is greater than 1, that's when we're working with growth, but you don't worry about your negative. You just look at that base number itself. So you just look at 2. All right, so these are just graphing exponential growths. When I see you guys tomorrow, I'm going to go over decay and show you guys what decay graphs look like and how we're going to identify that we're working with a decay graph. But if you have any questions at all on graphing these exponential growth functions, please let me know. Just complete that assignment today. I have that Google Meet if you want to hop on there too to ask me any questions. I know this stuff can get a little confusing, so I think it'll really help. All right, hope you guys have a good rest of your day.